So yes, here is your polynomials basics which you have to learn for the problem solution. So firstly, we have to discuss about definition of polynomials and coefficients, degree of a polynomial in one variable and two or more variable, polynomial of various degrees, number of terms in a polynomial, constant polynomials, zero polynomial, zeros of polynomials. So these are what the basic concepts we should know in order to solve the problems in this chapter. So yes, let us know what is the definition of polynomials. And firstly, before going to the polynomials definition, I would like to tell you people the definition of algebraic expressions, whereas we have interrelationship with algebraic expression and also polynomials. So here the definition of algebraic expression is algebraic expression having variables and constants and also binary operations in it. So such kind of expressions we can call as algebraic expressions. Let me repeat once again. Algebraic expression is an expression which has variables, constants and binary operations in it. So what is meant by polynomials now? So you people can see here you have a definition for polynomials. So polynomial is an algebraic expression in which the variable involved have only non-negative integral power is called a polynomial. So an algebraic expression in which the variable involved have only non-negative integral power is called a polynomial. So let us see how the definition holds good for polynomials here. So you can see this is a algebraic expression because, as I said before, according to the definition of algebraic expression, an expression which contains variables, whereas if we can say x, y, z are the variables, constants, you can see the numerical expressions here, so we can call them as a constants, and also binary operation which is minus and plus here. Since it is an algebraic expression which the variable involved have only non-negative integral. Non-negative integral in the sense you can see integral power in the sense you can see here we have 2 as a power. But here in this example, if you can see, we have 3 by 2. Integral power in the sense, non-negative integral power in the sense, we can take only the numerical numbers like this. We cannot go for the decimals or as fractions. Okay, so if you do 3 by 2, you're gonna get some decimal expression. That is why we cannot call this as a polynomial. We can call this as a polynomial because we have a non-negative integral power. Integral means 1, 2, 3, 4, 5, 6, so on, etc. numerical numbers. So we have one more definition for polynomial here. An algebraic expression in which contains variables, constants and binary operations with it is called a polynomial. Yes, so I can call this as a algebraic expression because it has variables, constants and also plus and minus in it. And how it will become a polynomial? If you can see, the only condition, the power should be non-negative integral power. You shouldn't have to get 3 by 2 or else decimal powers on the variable. Is it okay? So this is what the polynomial definition. And next you can see here the coefficients of polynomials. The coefficient in the polynomial, how it exists means, you can see in front of each variable you have a numerical term, isn't it? So whatever the numerical term you have in front of a variable, we can call it as a constant. Here in this particular example, I can take 4, 5 as a constant terms because they present in front of the variable. Wherever you see the numerical expression, whatever it is in front of the variable we considered, you can call them as a constant. Okay, let us come to second example here. What is the coefficient of x square here? Yes, in front of x square we have 3 by 8. So 3 by 8 is a constant term. Come to second term here. We have x as a variable. What is the coefficient of x here? Yes, it is 1 by 2 because we have in front of a x as a numerical term. So we can call 1 by 2 as a coefficient of x. Coefficient of x is 1 by 2. Coefficient of x square is 3 by 8.